All right, Sharon, so here's a look at your data, and I think I've identified where you're going wrong with the calculations. So let's take a look at it. Here's the equation up here that you ought to be using, and here you would put first the ABS of your sample, which if we're just looking at number one, you have 2.48, and that's going to be over top of your ABS of your standard DNA. So 2.16 is what you indicate right here, so I'm going to go with that. And we're going to set that equal to the concentration of your sample. And now that is your unknown. So that is actually your X. And then on the bottom is going to be the concentration of the standard DNA, which I'm seeing here is 0.125. So if I look over here at yours, I see that you put the weight of the sample there where probably you should have had your X. So if we just follow it through the way that I have it written here, we're going to cross multiply and cross multiply. So it's basically 2.48 multiplied by 0.125, and that's going to be set equal to 2.16x, and then we'll divide both sides by 2.16 to get rid of that on the one side and isolate our x, and then we can solve for what x is going to be equal to. So if I just punch that in really quickly here, okay, so when I do that, I get x is equal to 0.14 if we just round it, and that's going to be milligrams per milliliter. So that right there would be the extracted DNA concentration, so that's what would go in this particular place. And then from there, what we would do is we would take that amount, and I like to carry the units through because I think that'll help you to follow and make sure that you're on the right track. We multiply that by the volume that you extracted, which up here we can see is 47. So when I multiply that by 47 milliliters, the milliliters will cancel, and then we're going to get the number of milligrams of DNA. So if I take the 0.14 times 47, that's going to give me 6.58, and again that's milligrams. We really want to convert that into grams, and so that is your next step. And so we have 6.58 milligrams, and to convert that into grams we would put milligrams on the bottom, so those units will cancel, and then grams on the top. And in 1 gram there's going to be 1,000 milligrams, so we can cancel these units, and now we basically have 6.58 divided by 1,000. So when I do that, I'm going to get 0.00658, and that will be grams of DNA. And once we have grams of DNA, what we're left with, so grams of DNA would go in this place, and then once we do that, what we're going to do is convert this into a percentage of the total sample that we started with. So to do that, it's I'm just going to write it up top here because I'm running out of space. It's 0.0658 grams divided by the total number of grams that we started with, which is your 13.55, and that's in grams as well. And then I'm going to divide that out, and then also multiply it by 100 to convert it into a percent. So when I do that, in this case, I'm getting 0.048%, okay, which obviously is a lot lower than what you have there. Usually with these, we do get something that's less than 1% total. So that would be the value, this right here, the final extracted percentage of the strawberry, and with your data.